Hi, welcome to our video on the characteristics of the operation of electrical series and parallel circuit. Today, our focus will be on the series circuit calculation. Bear in mind what Ohm's law states when we are doing these calculations. Ohm's law states that the current flowing in a circuit is directly proportional to the voltage and inversely proportional to the resistance at a constant temperature. From that definition, it gives us what we call the Ohm's law triangle, in which voltage is represented by the letter V, current is represented by the letter I, and resistance is represented by the letter R. If you look also in our diagram or picture, you would see the formula which governs the calculation for these electrical quantities. It is important to note, however, the unit of measure for each of these quantities, in that current is measured in amperes, which is represented by a capital A. Voltage is measured in volts and represented by capital V, and resistance is measured in ohm, represented by the Greek symbol omega. Let us try these formulas in practice. Here we are given a series circuit in which we have three components having value of 2 ohm, 4 ohm, and 6 ohm, all connected to a 20-volt battery. And we are then asked to calculate the total resistance, the total current, and the voltage drop across resistor 2, which we denote as V2. Remember, from the Ohm's law, the formula which we use for the total resistance in series is RT is equal to R1 plus R2 plus R3 for this circuit. If we had more components in series, we would have added those components. Now let us substitute values for R1, R2, and R3 as they have been given in our circuit. Now that we have done that, we're just going to add them. And our answer will be 12 ohm. So therefore, RT would be equal to 2 ohm plus 4 ohm plus 6 ohm, which gives us a total resistance of 12 ohm. Now let us calculate the total current in our series circuit. Remember that in series, the current is constant. No matter where we measure in our circuit, the current that we'll get for a series circuit will be the same. From Ohm's law, the formula for the total current is the total voltage all over the total resistance. Now let us substitute values for VT and RT from our circuit. Now we would have realized that our total voltage is 20 volts, which is coming from our source, and we would have solved for RT previously, which gave us 12 ohm. Now, once we have substituted these values and we have done the calculation, our answer would be 1.66 amperes. What this means for a series circuit is that if we use an ammeter and measure in series at R1 or at R2 or at R3, the current, which we'd get would be 1.66 amperes. And that is what is unique about series circuit. Now we're going to look at the voltage drop. From Ohm's law, we realize that in order for us to find voltage, it would always be the current times the resistance. For our circuit, for a series circuit, we can use the total current in the circuit, because current is the same wherever we go, and times it by whatever resistance we'd like to find the voltage drop of. In this case, we're asked to find VT, and the formula we'll use is VT is equal to the total current, because it is series, times R2. Right, so we're using V2 is equal, we want to find the voltage drop of resistor 2, so therefore it is V2 for the voltage drop at resistor 2 is equal to IT times R2. Once we have substituted these values, IT we had found to be 1.66 amperes and R2 we have as 4 ohm. Once we have done this multiplication, our answer will be 6.64 volts. Go ahead and try using this same formula to find the voltage drop across resistor 1 and resistor 3. IT would be the same, and the only thing that will change is the resistor voltage, and our answer will be different. To find out if your answer is correct, one thing that is unique about a series circuit as it relates to voltage is that the total voltage is equal to the sum of the voltage drop across each component. What does that mean? It means that if we should find the voltage drop across resistor 1, the voltage drop across resistor 2, and the voltage drop across resistor 3, and we add those together, we should get 20 volts. In summary, from Ohm's law, our current is found from the formula RT is equal to R1 plus R2 plus R3, and if we had more resistors, we'd have added them. Current is constant in a series circuit, and it is given from the formula VT over RT. And lastly, if we want to find the voltage drop across any component for series, we can use the total current, because current is constant in series, multiplied by the value of the resistor which we'd like to find the voltage drop of. And for our question, what we were interested in is finding voltage drop of resistor 2, which gave us the formula V2 is equal to IT times R2. Feel free to comment below, and thank you for watching. Be sure to check out our next video on calculation of parallel circuits. Until next time, have fun studying electrical and electronics.